Hello, everybody. My name is Brianna Godot, and welcome to my portfolio project. Well, today we're going to be talking about a particular enzyme that I have been doing my project on for the past semester. Enzyme histone 4 K20 lysine 20 with N-methyltransferase. The organism that it is present in is Homo sapiens, also known as humans. Subcellular location will be chromosome, the telomeric region. Now, as we talk about the structure of the enzyme, the primary structure is 103 amino acids. You can see the sequence listed here. The secondary structure of this enzyme contains helixes, turns, and beta strands. The arrangement and placement of these can be seen below, as I have highlighted them to determine where you can see helixes, the beta strands, and the different turns of the enzyme. I have even listed out the number sequences that these are listed in and have separated these sequences for you to take a closer look at yourself. Now, as we move on to the tertiary structure, we know that this is the overall three-dimensional structure resulted from the folding and the covalent cross-linking of the protein. And we have a very squiggly looking line here. Moving on, we have the quaternary structure. This is the fourth classification level of the protein structure and refers to the structure of proteins which themselves are composed of two or more smaller protein chains. Now, the specific pathways which this enzyme functions is the lysine degradation. We have the sequence listed here. I would love to read this to you guys, but I am not confident in my pronunciation of these words. In here, you can see a much better image of the degradation sequences. The catalyzed reaction that takes place with this enzyme, we start with the substrate, what we start out with, the chemical compounds listed here. Once again, my pronunciation is not so good, so let me not butcher this, but you can see that this compound here combines with the histone 4 into position 20. That's where the K20 comes from. And the product we have here. And it sort of summarizes this reaction. The enzyme catalyzes the addition of a single methyl group of the lysine 20 residue of the histone 4. And this gives us better images. Now, the reaction parameters for this enzyme would be assumed that it functions within regular human body temperature since it's located within human chromosomes. So the optimal body temperature being 98.6 degrees Fahrenheit. Optimal pH balance would be a pretty natural balance of 8.0. Now, as we move on to the gene that encodes the enzyme, the official gene name being KMT5B, we look at the coding sequence and the length here of the NRAs. And this is actually a pretty long enzyme, the total length being about 2,658 nucleotides. We have about 885 amino acids plus one stop codon. And we know that this part is located in the chromosome 11 location. Now, as I said, the sequence here is very long, so I have it listed out here on two separate slides. And just to highlight the protein sequence that's located within the enzyme, much shorter, but still quite long. And that brings us to the end of our presentation. Thank you guys so much for listening. I apologize for any mispronunciations I may have made. I am not the most scientifically literate person, but I appreciate you sticking through the end. Here are the references I have listed here, and I hope that you hopefully learned something today, and you guys have a great rest of your day. Bye-bye.